Hi everyone. In one of my previous video, I implemented a RAG with the LLM DeepSeek, where it read the content from a PDF and based on the user's question, it give the answers back to the user based on PDF content. Basically, we can ask questions based on a PDF and the RAG will fetch the corresponding content from the FAISS vector database which has already saved from the PDF content. Using this content, it passes it to the LLM. LLM uses this context and gives the answers based on the user's question. Today we are going to build another RAG system using LLM Mistral. In this RAG system, we are using a Word document as the knowledge source and Mistral as the LLM. So we can ask questions based on the content in the Word document. This is the architecture of this RAG. Here, we are loading the Word document using Python. Then, read the Word document and return it as text content as the LangChain's document format. Then, breaks this text into overlapping chunks to preserve context for better semantic retrieval. Then creates dense embedding for each chunk. Add them to FAISS index for quick vector-based search. When a user asks a query, it encoded the user query into a vector, searches FAISS to retrieve top k similar chunks, return those chunks as a context. Basically, using this RAG, it combines user query plus context into a single prompt, send it to locally running model, which is Mistral, returns the answer generated by the model. The LLM model that we are using is Mistral, which is a high-performance open-source large language model with 7 billion parameters that performs impressively well across a variety of natural language processing tasks like question answering, summarization, and reasoning, like Llama 2 and even GPT 3.5 in some benchmarks. Mistral's key innovation is its sliding window attention mechanism, which allows it to process long context efficiently without needing excessive memory. It also uses grouped query attention to enhance inference speed, making it well suited for both cloud and edge deployment. The model is trained on a large high-quality dataset filtered from the web, making it strong in general-purpose knowledge and reasoning. To run this model in local, I am using Ollama. Ollama is a tool for running large language models locally on your own machine. To install Ollama, download and install the Ollama from their official website. Once you install Ollama, pull the required model from the Ollama repository. As I mentioned earlier, we are using model Mistral. To pull Mistral model, use this command. Here I am using Mistral with 7 billion parameters. Total size of the model is 4.5 GB. You can choose a lightweight model. Accuracy and performance will be depend on the parameter count. Once you pulled the model, you can list the pulled models using the command Ollama list. Next step is to install the required libraries. To install the required libraries, use this command. You can set up this application using virtual environment if you want to, so that you can isolate the project and their libraries. Here we use LangChain for core framework and community document loaders. Sentence transform is for embedding text. FAISS CPU for vector similarity search. Ollama to interact with local LLMs. Python Docx supports reading Docx files. NumPy requires for FAISS to handle embeddings. The purpose of split documents function is to split a large documents into smaller, manageable chunks of text so that they can be converted into vector embeddings and stored in a vector database. Here, we are using FAISS vector database. Splitting documents is essential because LLM have a context limit. Splitting helps the model focus on relevant parts of documents when answering questions. Here we create a text splitter object using recursive character text splitter from LangChain. Here we specified chunk size equal to 1000, which means each chunk of text will be around 1000 characters long. Also, we had specified chunk overlap equal to 200. Each chunk will overlap the next chunk by 2000 characters. This overlap helps to preserve context across chunks. Recursive character text splitter tries to split text at smart boundaries like paragraphs, sentences, or words, starting from the largest to smallest unit, so that the chunks remain meaningful. This is the major function of this RAG. This function takes split chunks of documents from split document function and converts them into embeddings and store them in FAISS vector database. The main purpose of this function is to store documents chunks as vectors in a searchable index, then search and retrieve relevant content based on user's query. Use it in our RAG workflow to give LLMs the right context to answer questions. Here I am using All-Mini LM L6v2, which is a pre-trained sentence embedding model from the Sentence Transformers library. It is one of the most popular and well-balanced models used for semantic search and information retrieval. It captures the meaning of a sentence, not just words. It is perfect for similarity search. Retrieve context. Purpose of this function is to find the top K most relevant document chunks from your vector store that match the query. Converts user's question into vector using sentence transformer. Then it searches the FAISS index for the K closest vectors to the query embedding. For example, let's say your document has 10 chunks and your query is who is the president of USA. This function will first convert the query into vector, compare that vector with all the document vectors, find 3 closest matches, return the matching text chunks. Generate answer with Ollama. This function generates an answer to a user's question by using the language model via Ollama and the relevant context from the document. Combines all the relevant text chunks into one big string separated by new lines and passed to LLM. Here we are also adding an additional prompt like you are an expert assistant trained on document information, which will help the LLM to get more specified content. Here we use temperature and max tokens. We set temperature value as 0.3, which controls the creativity. Lower temperature value means more factual content. Token value set as 2000, which is the max length of the generated answer. Purpose of this function is to format the matching document chunks and question into a prompt. Send it to a local LLM, which is Mistral, gets and returns the answer. So that's all about the code explanation. Let us run this code to test this RAG. To run the RAG, just run this Python script. I am using a Word document called Product Manual, which basically contains a sample demo content of a product called Smart Air Purifier 3000. I created this sample content for testing purpose. So here is my question to the RAG. How to use Smart Air Purifier 3000? It gives the proper answer based on the document, which is pretty good answer. Let me try another question. When should I replace HEPA filter? This time also we get a valid answer based on the content. So overall, the RAG gives valid answers with better accuracy. Response time and performance will be depend on your hardware. I also tried the same code with DeepSeek, which is DeepSeek R1 1.5b. It also performs well and gives structured output. When comparing these two models, DeepSeek gives me accurate and low latency output, but Mistral gives accurate content but with high latency. You can try with different models and different documents. I will share this code in the description box. Please check and let me know your comments. If you found this helpful, please consider to subscribe the channel and like the video. That's all about today's video. Thank you for watching and see you in the next video. Bye.